we then jump to the last lightning talk of today. There is indeed a bias in choosing Lukas as a speaker. We have Lukas Jansen from Fraunhofer IEE here in Germany, and he's talking about another PyPSA country model, sector couple bond with PtX features for South Africa. So Lukas, over to you.
Yeah, good morning and greetings from Kassel, actually, yeah, right in the middle of Germany. Many thanks for the interesting presentations so far and for having me here at this year's PyPSA user meeting. So I work at Fraunhofer IE, and you might know us as the developers of the open source grid modeling framework PandaPower, or from our interactive web tools like the Global PtX Atlas, Java Atlas, or most recently the locational Agora Meta. For the modeling work behind the study you see on the right, we choose PyPSA as the core framework, and together with Stellenbosch University, we built on PyPSA-RSA, currently developed by Klein from Meridian Economics, to create what we believe is the first customized multi-regional hourly resolved energy model for South Africa that includes sector coupling and PtX capabilities. In this short talk, I will give you a high-level overview of how we set up the model, how we combined it with our data models, and I will highlight some of its key features. I cannot go into all the scenario results. For that, please refer to the full study. On the next slide. So what were the key objectives of the PtX Allocation Study for South Africa, for which we developed the model? The first objective, and what was also actually a large share of the work, was to develop current scenarios through dialogue with key South African stakeholders, and of course by looking at the literature. So what was the situation back then? A recent study for South Africa typically focused on the electricity sector and were motivated by the energy crisis, with a, let's say, 10-year planning horizon. Or there are actually a lot of hydrogen focused study, but they are again then not so much linked with the general energy planning for South Africa. Well, together with the stakeholders, we then designed 3 main scenarios and somewhat extreme scenarios and sensitivities to conduct the study on long-term defossilization and scaling up of PtX with a high-resolution energy model. Consequently, the second model then was to develop an hourly resolved multi-regional cross-sectoral open source model for South Africa energy system. It can be seen as a complementation to the existing commercial Plexus model, which was back then 1 node and focused on the electricity market, and used by DME, for example, for the IPs. And as a combination to the time-spaced SATIM-GE model, which, well, they actually published some data sources which we used, and I will show that later on. The final key objective was then to evaluate the 3 scenarios defined, and evaluate the use of renewable energy and PtX to cover the future energy demands up to 2050. What is the history of PyPSA modeling for South Africa? The first PyPSA model was actually developed in 2017 already by Jonas Hirsch together with CSIR, using also profiles built by Fraunhofer IE around 10 years ago. Meridian Economics picked that up and updated the model version and extended its functionality to create PyPSA-ZA2 in 2023. For focusing on perfect foresight path optimization and on improving the representation of technology details, updating the data, for example, for the coal power plants and their availabilities. Peter and his colleagues, they also implemented a first implementation of multi-node model, and details like reserve margin and also special technology combinations. Meridian Economics then validated the results of this PyPSA model against Plexus, what I think is very interesting for South Africa. And they applied it to conduct an independent open source review of the IRP 2023 draft for South Africa, and I think Peter already also well presented the work done there at one of the last PyPSA user meetings. We fought from the version from end of 2023 and extended its functionalities, focusing on creating an 11-node sector-coupled energy planning model. Our focus, as I said, is 2030 to 2050. You already see the link to the repository if you feel to check it out. And there, just to prevent confusion, Meridian Economics, they also developed PyPSA-ZA2 further and created PyPSA-RSA, which has a more cleaner and better user interface. I would say the scenario configuration was improved and the pre-processing was refactored. So just so that you know, and there are plans to maybe merge some of our features we developed into his version, or into several directions. On this model overview slides, you see an overview of the markets and commodities that were considered, so not just electricity, but also heating, gas, fuel, reagents, or byproduct commodities, and CO2. As you know from other models like PyPSA-Earth or PyPSA-Europe. You also see the technologies that we considered implemented, so the storage, conversion, generation technologies. And just to summarize, the model instance simultaneously optimizes operation and investment decision for generation, storage, transport, and conversion technologies for the South African energy system to meet all the demands, and as it runs at hourly resolution for each of the years. Interconnection with neighboring countries in the South African Development Community region are currently not explicitly modeled and could be considered in future analysis. We used as much national data sources as possible and as were already used by PyPSA-RSA. So for example, ESCOM data for the power plants, IRP assumptions on fuel costs, Meridian data on investment costs. We then, as makes sense, and as I mentioned, we paid a particular focus on the detailed representation of links for the power to liquid synthesis. So desalination was explicitly modeled. We modeled the interaction of the synthesis processes with the and direct air capture with the heating market. And also we implemented the option to export multiple green products because export of ammonia or liquid fuels, green liquid fuels, was of importance or interest of the stakeholders for South Africa context. Just briefly, I mentioned, so what were the data models that we linked with the PyPSA model, which were most important? So we used the final energy demand projections, which are generated by the SATIM GE model, which is a times model actually, and which was used for the Just Energy Transition plan for South Africa. They published their data and we processed them and implemented an interface in that sense to PyPSA-RSA-Sec. And we also run our regenerants or energy ends tool to simulate profiles and identify most suitable areas for renewables. This looks like this. So here you see what are the model regions. The model regions we used the model regions which were defined by the generation connection capacity assessment of ESCOM, which is the grid operator in South Africa. We calculated or identified the suitable areas for all of these regions at high resolution, as you see, and we generated profiles and aggregated them per region, and the fallout hours are depicted then under the region names. And as you can see, for instance, the hydro cluster is a region with great resources, but as we learned, these regions have problems with water availability and are therefore not candidate for hydrogen electrolysis. Also, in the western regions of South Africa, we learned that there are problems with grid connections. So what did we do and used? We used the function of PyPSA-RSA to define regional limits. And how are these scenarios and these limits defined? Since this is different from other PyPSA models. I know. I want to briefly explain the Excel interface of PyPSA-RSA in this section, in this presentation. So in PyPSA-RSA and PyPSA-RSA-Sec, the main scenario options are defined via an Excel spreadsheet actually. The scenario wildcard in the index here is linked to sub-scenario options, which are then linked and used as a filter for the specific data tables. So for instance, the current policy, the CP scenario, for this, we select the option SCOM plan for the existing conventional power plants, which represents a later coal phase out than 2040. For the other scenarios, we define coal phase out by 2040. Other example, for the national and regional build out limits, we defined via the extender, can be defined via the extendable build limits, sub-scenario option, and the respective table. And also projected PtX volumes are then defined via the sub-scenario wildcard option projected exports, which you can see there are options low or high. And only the wildcard, which is called modified in the SnakeMake workflow, then is well integrated and used then for the files of the SnakeMake outputs. This is an interesting solution, I think. Now let me talk you through only 3 slides, snapshot slides of our results. So we identified that for all scenarios, unprecedented wind and solar installations, actually also for the current policy scenario, are the most cost-efficient energy source. We compared our results with existing studies at that time and identified that especially for wind, with different percentage differences of up to 280% compared to the IRP 2030 draft, for example, for 2030, shows that, well, especially our extreme scenario is way higher, and that if you want to reach the annual build rates of the required capacities up to 2050, also the required build rates far exceed current national plans, and this emphasizes the need to incorporate export potentials or export strategy into the future energy and grid planning of the well, energy and electricity system. Next snapshot, what about the hydrogen production? How much do we need? So we, as you can see on the left, we see that the hydrogen production reaches up to 8.660 million tons in the extreme scenario, driven by power to liquid extreme export assumptions. What do I want to mention here is we aligned our export definitions with the green hydrogen commercialization strategy, but we choose the higher scenario of this strategy. So as we learned in the last stakeholder workshop, is that actually the default scenario of this strategy is seen as more realistic, and this would then halve those numbers. So this needs to be considered. These are extreme scenarios. Where is the hydrogen electrolysis located? So actually the hydrogen electrolysis expansion is dominated by the Northern Cape, or close to the demand centers in Gauteng and Mpumalanga. This expansion in Northern Cape is actually in line with the ambitious provincial hydrogen strategy of Northern Cape. Anyways, it depends on if the new port plant here will be implemented or not, etc. Summary. First, well, to conclude, this PyPSA-RSA model now allows sector coupling, cross-sectoral, multi-regional scenarios to be defined via Excel configuration for key scenario options, and it uses an automated Python SnakeMake workflow for the rest. The model results provide decision makers with high-resolution scenario-based exploration of defossilisation and PtX focused scenario analysis up to 2050, so long term. It was developed as part of the PtX Allocation Study for South Africa in cooperation with Stellenbosch University, of course also with Meridian Economics. It was funded and supported by the International PtX Hub, Agora Industry, CSIR, and we got a lot of valuable feedback from various stakeholders. Thank you for this. we believe that its open source nature will facilitate future collaborations and developments also across different models and workflows. So we try to be in line with how PyPSA-Earth, for example, works, and this gives now the option to back and forth merge features. So we actually also at the moment figuring out which of those features will be implemented and tested here, for example, desalination or multi-energy product export could be implemented in PyPSA-Earth. Anyways, we learned that there are also others implementing this at the moment, so it's interesting to cooperate there. In general, we see that for PyPSA-RSA-Sec, the projection of final energy demands could be improved, and also using special sectoral demand profiles would be useful. A higher spatial resolution combined with improved representation of transporting and infrastructure would be interesting. Extending the analysis of the targeted production of PtX export products to other products like green HBI would add value, and also analyzing the potential of cooperation between different regions in Southern Africa would be interesting. This is meant by future developments. Yeah. On the right, you see the links relevant. And my last slide, you're welcome to join the PyPSA-RSA Discord for specific questions on PyPSA-RSA and PyPSA-RSA-Sec. It's set up by Peter Klein. Yeah, that's it from my side. Do you have questions? Thank you.
Thanks a lot for your talk. There are two questions in the chat, if you could answer them shortly. One by Johannes: have you compared PyPSA-RSA-Sec results with PyPSA-Earth for SA?
Not well, finally, but one major thing with PyPSA-Earth is that the default workflow for projecting the energy demands must be adjusted. So the projections with the default growth values, etc., are way higher than the national datasets project. But other than this, as we said, we work on using PyPSA-Earth in the project H2 Global meets Africa, and we'll continue with the comparison.
There's one more question by Marcos, which will also be interesting for me. How feasible do you think it will be to apply the Excel input way to PyPSA-UR? What exactly are you doing there?
Well, the added value of using Excel spreadsheet for some of the main configuration options is that it's easy to send around Excel files to stakeholders, and they can comment on the assumptions, etc. The downside is Git and Excel do not work so well, and you always have to commit and update the whole Excel file instead of different CSV or config files. And it is another layer of configuration. Yeah, so to be clear, so there's an Excel file, but there's also a config file and a snake make file. In the case of PyPSA-RSA-Sec at the moment, which makes it easier if you just want to configure the main options, but it makes it more complicated if you want to understand everything.
Yeah, look, there were quite a lot of models there. ZA, ZA2, RSA, and on. Do you have any observations on model proliferation in this case? Is it useful, beneficial, inevitable, or something to be avoided? Yeah, well, there was PyPSA-ZA, PyPSA-ZA2.
Okay, I see. Yeah. So I mean, as I presented, the starting point is there was already a PyPSA-RSA model, so we decided to pick that up. And there's not only this, there's I would say already a PyPSA modeling community. It's small, but it exists in South Africa, and they, for example, know PyPSA-RSA more than PyPSA-Earth, so it makes sense for us to build on this. Yeah, and other than that, I think it's important to we'll always check if it is necessary to create an extra model or not, if that's what you meant. But yeah, for the case of South Africa, there are lots of specialized data sets that we wanted to use. And for example, if we would have used PyPSA-Earth, we would have customized a lot of data sets used. And yeah, it was more. Peter Klein, if you want to add something, yeah.
Yeah, I just popped something in the chat to say, yeah, when we kind of started the journey, we had some very specific requirements that we needed to basically compare to the exact Plexos model that was used by the South African government, which has a strong focus on perfect foresight expansion with the low spatial resolution, for example. And so we obviously toyed a lot with like, should we start a new branch on that, or should we work from PyPSA-Earth or Europe? What we are working on is to try see how we can pull as many of those sort of more accurate data sets back into PyPSA-Earth, so we can kind of improve the South African representation in PyPSA-Earth over time as well.
Yeah, exactly.